So this question was asked in GATE 2018 Electronics and Communication Engineering paper, in which a binary source generates symbol X, which is -1 and 1, and this symbol is transmitted over a noisy channel, and the probability of transmitting this symbol X equal to 1 is given as 0.5. Now you have the received symbol R, which is equal to X plus N, where N is noise, and that noise probability density function is given by f of Nn, which is given by this graph. And if the detection threshold is 0, then you need to find out the probability of error in the received symbol. The NPTEL reference for this question is Principle of Communication System by Professor Aditya Jagannatham in the lecture Probability of Error. So the useful data for this question is, if you have two symbols S0 and S1 that is transmitted, then your received symbol will be R equal to X plus N, where X is your transmitted symbol and N is your noise. So if S0 is transmitted, then it becomes R0 is equal to S0 plus N. And if S1 is transmitted, then it becomes R1 is equal to S1 plus N. And the probability of error will be given by P of E is equal to probability of transmitting the symbol S1 multiplication with probability of receive symbol as R0 given that S1 is transmitting, plus probability of symbol S0 is transmitted into probability of receive symbol as R1 given that S0 is transmitted. So this is the probability of error expression. Now in the question you have given probability density function of noise f of n as from minus 2 to 2 and the amplitude as 0.5. Now when you transmit the symbol S0, which is equal to -1, then your R0 will be -1 plus N. So the PDF of the R0, the received symbol as R0, will be -1 plus this probability density function of noise. Similarly, when you transmit S1, which is equal to 1, then your R1 becomes 1 plus N. So you have this R0. When you add this -1 to this noise spectral density, then it will be from -3 to 1. So it will be from -3 to 1. So this is your 1 and this is -3 and this amplitude is 0.5. Now when you add +1 to this noise probability density function, then it is from -1 to 3. Now this is your when receive symbol is R1, then this is your probability density function, and this is when your receive symbol as R0, or you can take this one as capital R0 or this is capital R1. So this is your receive symbol when R0 is received, that is symbol S0 has been transmitted, and this is your probability density function when R1 is received and symbol S1 has been transmitted. Now what is this area? This area is the intersection of these two received symbol R0 and R1. So this is your probability. This shaded area will be give you the probability of receive symbol as R1 because it is the under the R1 region, because your threshold point is given as 0. So this is your R1 region, this area is your R1 region, so this is received symbol as R1, but given that this symbol has been transmitted as S0 at the transmitter side. Similarly, this shaded region can be given by probability, which is receive symbol as R0, but given that this symbol S1 has been transmitted at the transmitted side. Also, this value will be the area under this curve. That probability of R1 over S0, this is the area under this curve. So this area becomes 1 over, so this point is your 0.25. So you can find out the area of the triangle, which is equal to 1 by 2 into 1 by 4, which will give you 1 by 8. And this is also equal to 1 by 2 into 1 by 4, which is equal to 1 by 8. Now, you have the probability of error, which is equal to probability of transmitting the symbol S1 into probability of received symbol as R0, given that symbol S1 has been transmitted, plus probability of S0 into probability of received symbol as R1, given that S0 has been transmitted. So this value is 1 by 2, and this value, as you have calculated, 1 by 8, the area under this shaded curve. So this is 1 by 8 plus this is 1 by 2 and this is 1 by 8. So this will give you the 2 by 16, which is equal to 1 over 8. So this becomes 0.125. So the correct answer for this question is 0.125.